Hey, this is Roger, creator of the Azure Sandbox. I'm back. We just finished provisioning the VNet app configuration, and now we're going to move into smoke testing. So there's two sections to the smoke testing specific to the jump boxes, and then smoke testing specific to Azure files. So the first thing it asks us to do is to verify the node configuration for JumpWin1. This is similar to what we did in VNet shared for our domain controller. So I'm going to go up to Azure and I'm going to log in using my credentials, and we'll pull up our automation account. And if we go down here to state configuration, this we saw previously, this ADDS1, right? That was our domain controller. That was compliant. Now we have another VM that's been registered with Azure Automation Desired State Configuration. So that's JumpWin1, right? And you can see that it's showing up as compliant. If you click on these, you can get some interesting details sometimes. So our configuration included a bunch of different resources, and you can see here that all of those are reporting back as compliant by Azure Automation Desired State Configuration. So we know that the machine's domain joined, we know some Azure features were added, we know an AD group was created, we know that Chocolatey was installed, and then a bunch of Chocolatey packages got installed. And there might even be more detail on those. Yeah, so if I look at the Choco package installer, it shows all the different pieces of software that were installed and how long it took. Okay, so all that stuff looks good. If we look at our configurations, you can see we now have a second. This lab domain config was for our domain controller. That's part of VNet shared. We now have a second configuration for our Windows jump box, and we also have a compilation of that same configuration for JumpWin1. So that should be it for verifying that our node registration is compliant. Okay, next thing is to connect up to our virtual machine. So this will be the first time that we use the Bastion host to RDP into a machine. So the way we're going to do that is we're going to go up to our virtual machines, and we want to connect to JumpWin1, which is our Windows jump box. And I'm going to click on that, and we'll connect using the Bastion option. Bootstrap. Oh, that's why it's not connecting. I didn't have the right bootstrap admin at mysandbox.local. Would have helped if I'd copied it out of my documentation. There it is. That's why my logins were failing. So again, we'll do the password from the key vault. Connect. Hey, and we're in this time. Helps if you spell the user account right. All right, so we're running Windows Server 2022, and it still automatically launches Server Manager for that. So I think our next instructions are to disable Server Manager. So we will do that. Okay, and then we're going to inspect the mysandbox.local Active Directory domain. So we're going to launch a Windows Server administration tool for Active Directory users and computers, which we installed using desired state configuration. So this machine is domain joined, and we're logged in as the domain administrator. And here's my domain, sandbox.local. Okay. So if we look at this domain, we can see I've got two domain joined computers, JumpWin1 and JumpLinux1. I can see that I've got a storage account that has been associated with the domain. Okay, that's the name of my storage account. And that is going to be important for using domain credentials to connect to our Azure Files share. And if we look at domain controllers here, we should see our ADDS1 domain controller. So it looks like our domain is looking pretty good. Yep, that's everything. So the next thing we're going to look at is the DNS zone for my sandbox.local. So remember, we're running DNS in AD integrated mode. So we're going to launch a different administrative tool, which again, we pre-installed on here using desired state configuration. And we're going to connect up to the DNS server running on ADDS1. Okay. So on ADDS1, we are going to see our mysandbox.local domain, and then all of the private IP addresses for our domain controller, which is 10.1.1.4, for our Linux, our Windows jump box, which is 10.2.0.4, and for our Linux jump box, which is 10.2.0.5. So all of those host names have been registered with our DNS server, so DNS queries should work. And I think there's a couple of other things that we're supposed to look at here. Okay, so now we're going to, it wants us to click on ADDS1 and then double click on forwarders in the right pane. Okay. Double click on forwarders. Got it. Okay. And so what you can see here is we've configured our DNS server to forward DNS queries off to the Azure DNS resolver, which is this special IP address here, if it's not satisfied by our private DNS server. So that appears to be configured correctly. And we're also going to, I think we already looked at the forward lookup zones. So we already verified that that was working and that we had DNS records, A records for all three of our VMs. So that's good. DNS is looking fine. So the next thing that we're going to do is configure Visual Studio Code to do remote development on Jump Linux 1. So that is pretty straightforward. We'll just go ahead and launch Visual Studio Code, which we installed using desired state configuration and Chocolatey. So the binaries are already here on the machine. And we'll go to extensions and we'll search for remote SSH and install that as extension. Okay, cool. So remote SSH is installed. And then we're going to add a new SSH host. So we're going to go to View Command Palette. And if we type in remote SSH, you'll see all the remote SSH specific commands. And here's where we're going to add a new SSH host. All right, so what it wants is the SSH connection command. This one's a little tricky, so I'm going to copy it from here. So it's SSH bootstrap admin at mysandbox.local at jump Linux 1. That's the remote SSH command that we need. And we'll paste that in. And then it says it wants you to choose where to save this configuration. So we'll save it in the user's SSH config file. And that should be complete. So we've added the host. Now we're going to connect to it. So this is another remote SSH command. So I'll say command palette remote SSH connect. And you can see now jump Linux 1 is listed because that's in our configuration file. So I'll click on jump Linux 1. And that's literally going to launch another instance of VS Code, which is now set up to do remote development against jump Linux 1. So the first thing we have to choose here is what kind of SSH host it is. It's a Linux host. It's going to confirm that we want to trust that machine by displaying the fingerprint. So we'll select continue. And then we need the password, which we're going to need to get from Key Vault. So it's going to be the same as our admin password. So we'll pull up the Key Vault. We'll pull up our secrets. We'll pull up our admin password. And I'll copy it. And then we'll paste it in here. So down here you can see setting up SSH host jump Linux 1. Well, that's good stuff. You selected Linux as the remote platform. This will be stored in the setting, blah, 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 and can be changed there if needed. Thank you so much. Okay, and down here you can see that we're now connected to jump Linux 1. So we're RDP'd into jump Windows 1 using Bastion. We've created a remote SSH session from Visual Studio Code to jump Linux 1, and now we can use that to do remote development against jump Linux 1. So the next thing that we're going to do is we're going to connect to the remote file system on jump Linux 1. So that's like a separate SSH connection. So if I click on, let's see, what is it telling me to do? Go to View Explorer, click Open Folder. So we'll open up the Explorer, we'll click on Open Folder, and by default, it's going to try to open up the home directory for your user account on jump Linux 1. So I think we'll take that as the default. And it's going to be the same password from Key Vault. So there's two connections. There's the SSH connection, and then there's the file connection from the Explorer. So I'm going to go ahead and say, yep, I trust all the code on this machine. We're all good. So on the left, you can see in our Explorer all the files that are in my home directory on jump Linux 1. And if I do a view terminal, I have a bash terminal against jump Linux 1, and now I have a fully capable development environment against my Linux machine in the sandbox. And there's some software pre-installed on there. So I think if we do an az-version, we use Cloud Init to install the Azure CLI. So that's pre-installed. If we do pwsh version, PowerShell is pre-installed on that Linux box, And if we do Terraform -- version, Terraform is pre-installed on that box. So now we have a fully functional development workstation in our sandbox. It can be used to develop against Windows or to develop against Linux. So at this point, you can switch over to using Jump Windows 1 as a developer workstation, or you can continue using your remote client environment. It's up to you. Let's see what else we need to do here for our smoke testing. Okay, we did all that stuff. Now we're going to move to Azure Files. So the first thing that we want to do is make sure that the private DNS zone for our Azure Files share is going to work correctly. So we need the fully qualified domain name portion for the Azure Files endpoint on our storage account to do that. So let's go look at storage accounts. And you can see my file share is created on here. And you can see the endpoint here is listed. So I'm going to copy that. That's just one way to get the endpoint. And what it's asking us to do is to do a resolve DNS name. So let's just run PowerShell to do that. And we'll do a resolve DNS name. And I'm going to get rid of the URL portion and just put the fully qualified domain name for the Azure Files endpoint. So didn't like that. Why didn't it like that? Oh, I know why it didn't like that, because I need to get rid of this too. Okay. All right, that one worked. So what we've done here is we've said, hey, here's the fully qualified domain name for our Azure Files share if it were a public endpoint. We've set up a private endpoint for it. And what we've done is we have configured our DNS to point to that private endpoint. So now we're not going to a public IP, we're going to a private IP 10.2.2.4 to connect to that Azure Files share. So that worked pretty good. So we verified it is a 10.2.2 address. These are the different resources that were involved in making that happen from our Terraform configuration. And now what we're going to do is we're going to actually try to map a drive to that file share. Now, notice I'm not using any credentials here, so it's going to use integrated Windows authentication to try to connect. And what am I trying to say? I have domain joined this Azure file share, and I'm logged in as the domain admin, so it's going to use my domain admin credentials to connect. Keep missing it. One more time. Okay, got it. I think this is right. netuz:// and then the fully qualified domain name of our Azure Files endpoint, followed by // followed by the name of the file share. That should work. Boom. So we've got a Z drive now. And so instead of having to create a whole separate virtual machine and set up a file share on it, instead we're using the platform as a service capabilities in Azure to create an SMB file share using Azure Files, which is a service that runs on top of Azure Storage. And we are using Active Directory integration for the authentication to that file share by domain joining it to our mysandbox.local domain. And I'll walk you through the code for how to do that later. So I think what what the smoke testing is going to ask us to do next, whoops, wrong file explorer, is to go create a test file or something on that Z drive. So if I pull up Explorer, here's my Z drive, which is my file share, and I'll create a test folder. And I'll create a new text document called readme.txt. And in there, I'll say, hello, world. So there you go. You've got Azure providing SMB file shares using a platform as a service option. And we now have a file share that we can use to share files between the various systems that are included in our sandbox environment. Pretty cool. Create some files, blah, 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 blah. Oh, this is important. Note, SMB connectivity with storage key authentication to Azure files via the internet will not be tested because most ISPs block port 445. So if you try to use Azure files over the public internet, it's probably not going to work because of the security concerns. Most ISPs shut down port 445, which is what SMB uses. So we're not going to try to get that to work. We're just going to use private endpoints and private access to SMB just inside of our sandbox environment. Okay? So in the next video, we'll do a code walkthrough of all the code that's involved in VNet app. Thanks, everybody.